Good morning, both of you.
Good morning, sir.
Good morning.
Good morning, sir.
Turn on your videos as well, please. And now we were at a point. Acha, I have shared the notes, a notes link with you. Okay. So
Sir,
if
do
you
we
want,
have homework after the second class?
we have the homework after the third class, which is combined with the second class actually.
Okay, sir.
Okay, so don't worry about that. And then the thing is, we have discussed the mass spectroscopy, mass spectrometry, right? In the last class, you remember? We have
Yes,
plotted
sir.
some graphs and all. So, you with the help of mass spectroscopy, what we tried to calculate, if I ask you, what we tried to calculate that time?
Atomic mass.
Average atomic mass, not
Yes,
atomic
yes.
mass, average atomic mass we have tried to calculate there. So then, if let's say you are given with the average atomic mass itself, and you want to find the percentage of some isotope which exists of any species. Can we do that? Yes, there is no fault in doing that. Hey, you guys, please turn on the videos as well. I told you multiple times that it's important to do it. An element X has three isotopes X20, X21, X22. Okay, the percentage abundance of X20 is 90%. It's given to you. And they are also saying that the average atomic mass of element X is 20.11 U. Okay. They are saying to find the percentage abundance of X21. Can you do it? Can you do this thing quickly? We know how to calculate the percentage abundances, right? I mean to say average atomic mass. It's nothing but to calculate the average atomic mass, it was nothing but summation of, like this. This is a symbol for summation. Summation of mass number of ith element, whatever the isotope you are taking, into the percentage of that isotope. Percentage abundance of that isotope. And this is the summation. That means you have to do it for all the isotopes present there. See, I will not repeat once more. Please turn on your videos. You can even unmute yourself also. We can have a connective session. That's better. AP is all about connectivity. Teacher and student connectivity. If it's good, then I don't think so. You will be getting any problem here.
Sir, it would take 5 minutes to on the video, sir, for me.
It's fine. It's fine. You can at least tell me, okay, that okay, you will do it. It's fine.
Yes, sir, I'll do it.
Okay. So do this question. This kind of questions can also be asked in the AP exam.
Yes, sir.
Any answers? I'm expecting something fast. If you are facing any trouble, then I will do it. Tell me, please.
Sir, here there are three isotopes now. One is given 90% abundance, so the other
Hmm.
two becomes 10%.
The other two becomes 10%. Yes. So
But
take
we
one.
don't know their mass.
Hmm. That is what actually, you know the mass is right. The mass number is given to you, isn't it?
Yes, sir.
So then,
But
percent
here you said 20.11. So is
that
there
is the
any?
average atomic mass given to you, right?
Okay. So should we take 21 and 22 like that only?
Mass is that. The percentage abundance of X21 and X22 is not given to you.
Yeah, but that is the problem, no? If we take x into 21 plus y into 22 by 3,
Not why you are taking y, because you know that
x
the
plus y is 10.
X plus Y is 10, then
Okay, 10 minus
X,
x we can take. Yeah, yeah.
yeah, you can do it in one variable itself.
Okay, sir.
Yeah, please tell me the value for that X. X is you Mrinal has taken X for the percentage abundance of X21 isotope. Ram, are you getting this thing?
Yes, sir. Doing, sir. Last.
Okay. Okay, so can I do it in this way?
Sir,
20,
9 and 1, sir.
9 and 1. It's fine. 20.11 I am writing over here, and the mass number of 20 x20 is 20, and the percentage of abundance is given as 90% plus. I am assuming that x is my percentage abundance of 21 isotope, so x into 21 plus 10 minus x, then it will be remaining for 22 divided by 100 because it's a total percentage. So 100 I can bring over there, and you can solve this value. You will get the x value which you want to calculate, which is 9%, coming out to be 9%, and it's done. It's fine, both of you?
Yes, sir.
Yes, sir.
Okay, cool then. Now comes the new topic for today's class, which is stoichiometry. Stoichiometry. So what do we mean by stoichiometry? Let's say any reaction is happening, something like this. A plus B gives me C. What do we understand with this A plus B gives us C? We can simply understand that one molecule of A reacts with one molecule of B to produce one molecule of C. That is what it says actually. The stoichiometry what it says. One molecule of A, if it reacts with one molecule of B, then only it will give you one molecule of C. Okay, I think it's fine. Then there is another thing also. Let's say some different equation we will take. 2a plus 3b gives me 4c. So what do we understand from this equation? That when two molecules of A reacts with three molecules of B, then only it will produce four molecules of C. I think it's fine, right? Okay. Then what is this? What are these values? These are called stoichiometric coefficients, which tells us that okay, how many molecules of A are required to react with how many molecules of B to produce some molecules of C. Is it okay for you? It's fine.
Yes,
So,
sir.
if you can answer this in terms of number of molecules, you can also answer this thing in terms of number of moles. That means you can answer it in this way that 2 moles of A requires 3 moles of B to produce 4 moles of C. This is how we have to read a chemical equation. This is how we can read a chemical equation. Very, very important to read how to read a chemical equation, because stoichiometry combined with the gaseous state is their favorite question in AP. Stoichiometry and gaseous state they will combine. Limiting reactant or gaseous state they will combine, and it's the favorite question. Okay. So this is called reading of a chemical equation. I will tell you more in
Sir, we
detail
can
about
do
this.
it in moles or atoms or molecules also.
Take always moles. If
Okay.
grams is given, if number of molecules is given, first try to find out the mole. That is what AP says. Try
Okay,
to
sir.
figure out what are the number of moles, and we will solve everything with respect to mole. And then if they are asking me some grams, weight, or some number of molecules, we will convert it back using y bar. It's fine.
Okay, okay, sir.
Okay, cool. Then, if this is called reading of a chemical equation, I hope the reading is understandable from here, right? How to read. 2 moles of A requires 3 moles of B to produce 4 moles of C. I hope this is clear. Then let me give you a direct question. A direct question says that 27 gram of Al reacts with, okay, reacts completely, reacts completely with what grams of, what amount of oxygen gas to produce Al2O3. Okay. So first of all, whenever these kind of questions are asked, are going to ask, like they are asking from you that okay, if someone's mass or someone's moles is given to you and you want to find out some other one's mass or some other one's mole, okay, this amount they're asking in terms of grams only. That is, let me clear you. So they're asking you the grams for oxygen. You are already given the grams for aluminium. How can we proceed it? How to do it? So first step, write 4 steps, and after writing the 4 steps, you are good to go. You can solve any question now. See, the first step of these type of questions is to write the chemical equation. Write the chemical equation. The second step is to balance it. Balance that chemical equation out. The third step says that after balancing, read the chemical equation. Very, very important. You have to read the chemical equation which you have written. Okay. So how to read the equation? Something like this. This is how we will read a chemical equation which I have written in the green. Okay. And the last step is now check the data. That means data we are not concerned about. We will check in the end. Okay. Now check the data and solve. And solve it normally. Like, how will you solve it? You can say it, we will be solving it by simple maths. Solve it by simple maths, nothing else. Okay, basic maths you have to use here. Okay, let us
But
try to.
balancing chemical equation वो एक स्टार्ट मेथड होता है ना सर, like first method and second method, like acid. Okay.
Oh, that way. Okay, so actually, how to balance a chemical equation? It's like you balance the metals first.
Yes sir,
Okay,
yes sir.
balance the metals first, then go to non-metals except oxygen and hydrogen. Never balance oxygen and hydrogen at the first place.
Yes
Okay.
sir, yes sir.
Then balance the hydrogen, and in the end, in the last, balance the oxygen. That is how we balance it. Okay.
Okay sir.
We will read it more about in redox reactions when you will be balancing more of the equations in acidic medium and basic medium. Okay.
Yes
Okay.
sir.
It's fine. Then, so let us quickly write the let us follow the steps and write the chemical reaction first. So they are saying that aluminium is reacting with O2 gas, oxygen gas, to produce Al2O3. That is what reaction they are saying. Now we have to balance it out. Can you balance it out quickly, both of you?
Yes, sir.
Yes sir.
Please
2Al
do it.
plus
4Al.
3O2.
Yeah, I think it's fine. If you can balance this much. Okay. Then balancing is done. Then what is the third step? Sir, read the chemical equation carefully. Read it. Carefully read it. What the chemical equation says you. Chemical equation says me that I require 4 moles of aluminium, which to require 4 moles of aluminium requires 3 moles of O2 to produce 2 moles of Al2O3. Is it okay for you? That is how we are reading a chemical equation. Is it fine? Now check the data and try to solve it and check what they are asking actually. See, let us go above. See, they are saying you that 27 gram of aluminium is given to you. That means we have to use aluminium somewhere. Okay. Reacts completely with what amount of oxygen gas? Okay. So they are asking us to link aluminium with the oxygen. Is it okay for you? Fine.
Yes, sir.
They are saying us to link the amount of aluminium with the amount of oxygen. That means, sir, whatever you have, however you have read the equation here, this one, how you can link the aluminium amount and the O2 amount, sir, it's nothing but I can simply say 4 moles of aluminium is requiring 3 moles of O2. Now see how I am establishing a connection between moles of aluminium and moles of oxygen. Is it fine for you?
Yes,
It's
sir.
fine.
Yes,
Ram,
sir.
you also? Then okay. Now, how much mole of aluminium is actually given to you? That is what the question. That is what the reaction says. This is a reading of a reaction which we have done here. Now, how much mole actually is given to you, sir? We are given with a 27 gram of aluminium, and aluminium has the mass number of 27 as well. That means how many moles of are given to you? Given with you, sir? It's just one mole.
1 mole.
1 mole. Yes. So if I know 4 moles requires 3 moles of O2, then 1 mole will be requiring how much amount of O2? Sir, it will be nothing but 3 by 4 mole of O2. Isn't it? Yeah. I now have the mole of O2 which I require to completely react with 1 mole of aluminium. But they have not asked me the moles of O2 which I require. They have asked me grams of O2 which we require. So we have to convert this mole to grams. How do we convert mole to grams? By multiplying with the molecular mass, isn't it? Yes. So it will be 3 by 4. What is the molecular mass of O2? 32. So you do it, it will be 24 grams. Yes, this is the final answer. Is this clear?
Yes, sir.
100% both of you? Fine. If
Yes,
yes,
sir.
then I will move ahead. Okay. So what we did, listen to me very, very carefully. First of all, we have write a chemical equation. Written a chemical equation. We have balanced it out. After that, yeah, after that, we have read the chemical equation as well. Okay, how to read the chemical equation? Like this. Then, then we try to check the data and try to solve it. How to solve it? After reading the data, you will understand that okay, what relations are there with what thing you want to find the relation. Is it fine for you? Okay, like here with the aluminium, I want to connect a relation with, I want to get a relation with the oxygen gas, which I have done here then. 4 moles of aluminium requires 3 moles of O2. Is it fine for you? Can I move ahead? Yeah?
Yes, sir.
Okay, cool then. If this is also clear, then I can give you one question to do quickly, and then we will further move ahead. So find the number of moles of NH3 formed by complete complete combustion of 15 into 10 to the power 23 molecules of N2 with required H2. With required H2. Hmm. So what is my first step to do? Write a chemical equation and balance it. 2 steps we have to do it, first of all. Okay, let me know the equation first. We will do it together. See, you guys can speak, I can write. You guys can speak, I can write. Whatever you are writing in your notebooks, I will also write here.
N2 plus 3H2 gives 2NH3.
Okay, that is the good balance equation. N2 plus 3H2 gives me 2NH3. Now, what is the third step to do?
Read the equation.
Read it. Please,
1 mole
Mrinal,
of
you try to
N2,
read this equation.
1
Yeah.
mole of N2 plus 3
1
moles
mole
of
of N2
requires 3 moles of H2 to give 2 moles of NH3.
requires 3 mole of H2 to produce 2
3
moles
moles of
of
NH3.
NH3. I said, okay. Now, what is the next thing we have to do?
Can you go a little up, sir? I
Solve.
want to see the question.
We have to see the question. We have to then solve the question. See the question, like what relation they are demanding from you. They are asking you find the number of moles of NH3. Okay, that means NH3 must be involved and formed by complete combustion of 15 to 10 to the power 23 molecules of N2. That means they are saying establish a relation between N2 and NH3. So can we, after this, from this equation itself, can we do that? Yes, 1 mole of N2 forms 2 moles of NH3. That is my relation. That means, sir, 1 mole of N2 forms 2 moles of NH3. But how much moles of N2 do you have?
15 into 10 to the power of 23 by 6.022 into 10 to the power of 23.
Okay. These many moles of N2 I have. I said it's totally fine. Please try to calculate this out using your calculators. Give me the exact value. Up to
15
3
by
decimal point.
6.022.
Sorry? What you are saying? Sorry?
We have to calculate 15 by
6.022.
6.022.
Yeah, yeah, yeah. Yeah. How much you're getting? 15 by 6.022.
2.490.
2.49. It's fine. Okay. Then that means I am having how much moles of N2? 2.49. One, if I had 1 mole, I will be getting 2 moles. If I am having 2.49 moles, then how much I will be getting?
4.98.
2.49 into 2. That means it's nothing
4.98.
but 4.98 moles of NH3. And did they ask you the moles or did they ask you the grams for NH3 calculation? They asked us
Moles.
moles itself. So
Moles.
that is our
Yes.
final answer. 4.98 moles. I hope,
Sir,
Ram,
the
you are also.
questions we are doing, the two questions we did, it is AP level only.
They are AP questions itself.
Okay.
Not level. They are AP questions itself.
Okay, sir.
Okay? Don't worry. I said, na, just trust me. Just trust me.
Yes, sir. We all
Okay.
trust you.
Yeah. Okay. Ram, is it fine? The previous question?
Yes, sir.
Good, very good. Okay, let's move ahead, a little ahead. If X moles of O2 required and Y moles of CO2 formed during complete combustion, do you know what is a combustion reaction? Anything you react with O2, oxygen gas, and form some oxidized products, that is called a combustion reaction. Okay. During complete combustion of 2 moles of carbon, then find the value of x square plus y square. This is what you have to do. If x moles of O2 required and y moles of CO2 formed during complete combustion of 2 moles of carbon, then what is the value of x square plus y square? You have to follow the same rule. Write a chemical equation, balance it out, read it, and solve it. Now, this is not a AP question, first of all. Let me clear this. But this kind of questions can be asked in AP. It's their pattern itself. Yeah. How we can do it? They're saying 2 moles of carbon is getting combusted. Can you write the chemical equation for it? This time I want you, Ram, to tell me the answers or help
Sir,
me out. Mm-hmm.
is it C plus O2 gives CO2?
Yeah. It's fine. Yeah, Ram, yes.
Sir, 8, sir.
Acha, though you told the final answer, that's fine.
Yes, sir.
Okay. Mrinal, now you have to calculate final answer yourself and let me know how much you're getting.
Same, sir, 8. 2
Okay,
square plus
so
2 square.
yeah, so do you guys like to eat sandwiches? Both of you?
Yes, sir.
Yes, sir.
Okay, then if I ask you how a sandwich is made,
Bread,
maybe we can add some bread. How much pieces of bread is required to make one sandwich? Two bread
2
pieces, let's say,
slices.
for ones, two slices of bread. So then let's say that I also require two lettuce to add in that bread, and on top of in between the two breads. Okay, two lettuce is required. I let me assume that three tomatoes are required. Three tomatoes are required, and let us say that what else do you add in your sandwich usually? Cheese
Cheese.
slice. Yeah, okay, so let's say one cheese slice I want. Okay, this is how I can make a complete sandwich, a one complete sandwich. Okay, if you have this amount of these things, you can make a complete sandwich. This is three tomato
Sir,
pieces, not three
paneer या
tomatoes.
chicken नहीं रखेंगे.
No, I am a vegetarian. I will not cook
That's
chicken.
why paneer, sir.
Okay, paneer also you can add. Okay, fine then. How much pieces of paneer then I can add? Okay, let's add then 4 pieces of paneer in one sandwich. Okay, 4 pieces of paneer. Now the question is, sir, this all information you require to form just one sandwich. I said, okay, it's fine. If this amount is given to you, let's say that I am giving you two breads. I am giving you two lettuce leaves. I am giving you three tomato pieces. I am only giving you one cheese slice, and I am giving you four paneer pieces. So, will you be able to form a sandwich? Yes, sir. There is no problem. I can form a sandwich. There is not a single problem with this thing, isn't it? Yes. Yeah. So then let us say that now someone else is there. Someone else is there who don't know how you like to eat sandwich. I like to eat sandwich in this way. I like to eat sandwich like this way. But someone else is there who gave you 5 pieces of bread. Sorry, 6 pieces of bread. Let's say that. You are having 6 pieces of bread. Then someone also gave you 20 uh 20 lettuce leaves. Okay. Then someone also gave you 10 tomatoes slice pieces. Okay. Then someone also gave you let's say 4 cheese slices, and someone also gave you 10 pieces of paneer. So with this information, how much sandwiches you can make, and one sandwich must contain these things in the required proportions. If I ask you, tell me quickly. With this information, this required information, how much sandwiches you can make? Okay, let's say
2,
that
sir.
with 6 pieces of bread, how much sandwiches are possible? If I am having 6 pieces of bread, then how much sandwiches are possible with 6 pieces of bread? Only I'm talking about bread.
3.
Three. Okay, three are possible. If I'm having 20 lettuce leaves, then how many sandwiches are possible to make? Sir,
Ten.
one sandwich requires two lettuce. So 20 will be 20 can make 10. I said okay. 10 tomato pieces if you have, then how much sandwich you can make?
3.
3 again. Then if we are having 4 cheese slices, then I
4.
can make 4 sandwiches. If I am having 10 pieces of paneer, I can only make 2
2.
sandwiches because per sandwich I am adding 4 paneer pieces, isn't it? Yes. Yes. That means, sir, uh, okay, if everything is given you in a combined ratio, then how much sandwiches you can make with this
2.
amounts only? Sir, which is the limiting reagent here? Which is the limiting amount here? This
Paneer.
two, the paneer, if you give me more, I can make even more sandwiches, but I am not giving you more paneer. I have just given you two pieces,
Sir, for
like,
one sandwich, we can make we need 4 pieces of paneer. By
yeah.
10, we can make 2.5 sandwiches
There
now.
is nothing like 2.5. You want to make either a complete sandwich or not a sandwich here. You can
Okay,
make it, I know it, but I for now in this case, we are making a complete sandwich. So I'm not considering that 2.5 or something like that. Okay?
okay,
Because
sir.
to make things easier. Okay?
Yes, sir.
Okay. So that means, sir, this is deciding me. This is telling me that how much sandwiches I can make. The pieces of paneer only is able to tell you how much product in the final you are able to make. The rest of the things I am not concerned about. Only the paneer, which is in the lesser quantity, the species present in the lesser quantity will tell me how much sandwiches or the product can be formed. And this kind of species is called your limiting reagent in chemistry. Limiting reagent. And the and the rest of the things are called the excess reagents. Now listen to me very carefully. They ask you about excess reagents. They ask you about the limiting reagents as well. Okay, let's say we have completely formed two sandwiches. So how much excess reagents we are left with? That can be a question, which we will discuss later. Okay, they can ask you something like this. Okay, I think this is fine. You understood what is a limiting reagent, which decides the amount of product formed. Limiting reagent decides the amount of product formed, nothing else, no one else. Okay, then you can ask me, sir, then why you haven't considered the concept of limiting reagent over in this question or the previous two questions as well? Because here it is written that a complete combustion is happening, a complete reaction is going on, complete reaction. Oh, sorry, this is not combustion, this is a reaction. Complete reaction is going on. A complete reaction was going on. Complete reaction means everything is present in the like equal proportions which is required actually. Like this is a complete reaction. This is a complete reaction. This thing is a complete reaction. But this thing, in this thing, if you go, it's not a complete reaction because some things are getting left, some things are getting used up early. Is it okay for you? If everything is present in just the required amounts, then that is reaction is called a complete reaction. There is nothing excess, there is nothing limiting. So if you can see here, it's a complete reaction, it's a complete reaction. It's this is also you can see if it's also a completely reaction. So whenever you can see this word complete, completely, completely, or whatever, this is like you have to solve the question using normal stoichiometries. But what if this is not given to you? This complete thing is not written over there. Then what type of question that would be? It would be the question for a limiting reagent. Is it fine? Is
Yes,
it
sir.
fine? Okay. Okay then. So let us now talk about limiting reagent. Okay. Chalo. Let's proceed it. So limiting reagent, as you understood now, if you have understood this, then can I quickly give you just one question for this? That 5 moles of CH4 is burnt with 8 moles of O2, then calculate moles of CO2 formed and moles remaining moles of excess reagent left. So if you can see here that okay, they are asking you the excess reagent left, that means this question is of a limiting reagent. This question corresponds to the limiting reagent topic. If this is the scenario, then how shall we proceed? Same way, write the chemical equation first, balance it out, and after balancing, wait for a second. After balancing, wait for a second, give yourself some time. Why, sir? Because after balancing, you need to find out which is the limiting region. You have to find out after balancing itself which is the limiting agent. And sir, how to find the limiting agent? There are many teachers which tells that okay, do this, do this, do this. Very, very long methods. I am not in favor of that because AP just you have to solve the question and it's done, right? So what we will do, we will try some short trick here. Okay. See, can I write a balanced chemical equation for this? Can any one of you tell me the balanced chemical equation for this? Maybe quickly. The balanced equation. Fast, fast, fast. Any balance equation you give me, yeah. This for this one. We are having CH4, we are having O2. Combine them together to produce what? What it will give you? Do you know?
CO2 plus H2O.
CO2 plus H2O. I said okay.
Sir, there is
Then
a like fixed equation, sir. CXHY plus Y by 2O2.
sorry, huh? Yeah. It's fixed. For carbon containing compounds, it's fixed. Okay,
What
for
will be the
hydrocarbons
equation,
basically.
sir?
Sir, here 2O2 and 2H2.
Sorry?
Two balance equation, sir.
Huh,
2O2 and
balance. Huh,
2H2.
two, you said two here and O2 is how much?
2, sir.
That also
Sir,
two.
if
It's
you can you give that equation CXHY plus that O2 and
Acha, that is not required, and that will vary. Okay, you can write it. It's not a problem. CXHY if you have, then we can react with some amount of this O2 to produce you X amount of CO2 plus Y by 2 amount of H2O, isn't it? Yes, it is like that. And then regarding the O2, if I ask, so O2 will be how much? It will be first of all X plus O2, right? So X plus you can say Y by 2 I'm writing. So X plus Y by 2 itself. Y by 2 is O. So it for O2 it will be Y by 4. Okay. So X plus Y by 4. Yeah, this is the equation. Okay. Just let me check this once. No, I think there's some problem here. It should be y by 2, I guess. Wait. Yeah. Yeah, it's fine. 1. Am I doing some mistake here? Because I never
सर
remember
वन
this
प्लेस आई
equation.
थिंक y by 4 कम सर एक एक जगह में y by 4 आता है.
I think here it should be y by 4 itself. I'm trying to figure it out if it's working on the above equation or not.
Yes sir, it's
It's working. So 2
नहीं
here,
y by 4 it's somewhere between for y by 4.
1, 2 and 2. It's 4. And this is also 4. So 2 I'm using over here. That means
नहीं sir, I
1.
think it's x plus y by 4. It's near O2, it's x plus y by 4.
I am thinking that itself that it should be either y will be how much here it will be 2, right? So y by 4 if I do, no, I don't think so.
It's
Uh,
x plus y by 4 sir.
if it is x plus y by 4, can we use it for the above equation? Try it. I am also remembering that it's x plus y by 4, but I never memorized this
Yeah,
equation.
yeah, it's balanced sir.
It's getting valid for
Yeah,
his here also. Let's see it. So it will be like you put what is the value of x here? 1. Okay, what is the value of
y is 4.
y is 4? Yeah, it's fine now. Yeah, it's working. Yeah, it's fine. Yeah, I wrote it.
Sir,
Wrote it
accessory
down.
agent,
Okay.
answer 1, sir.
Sorry?
Answer is 1, sir.
Answer is 1. Like what you calculated?
Sir, like
The
for
moles of
4,
CO2 formed.
sir?
So you have calculated the moles of CO2 formed?
Yes, sir.
No, the answer is not 1 then, I guess. Let us try
Is
to
it
solve it
5?
out.
Is it 5?
No, the answer is not also 5.
Sir, like remaining accessory agent is 1, sir. Number of moles
Remaining
formed.
remaining excess reagent is what? CH4 it is? That is 1. And what else you said? Amount, how much it's forming for CO2?
CO2 5 moles forming, sir.
CO2 5 moles are forming. No.
Sorry, 4 moles.
Yeah. Now see here how we can proceed this. Listen to me carefully. Once we have written the balanced chemical equation, acha, this equation, if you want to remember, you can. But see, in my entire life, I have never memorized this equation because there is no need. Okay. Then, okay. Now, once you have written the balanced chemical equation, what you can do? You can simply take the ratio of mole by stoichiometry of each of the reactants. Of each of the reactants. Let us do it. What is the mole given to you in the data? 5 moles of CH4 is given to me and 8 moles of O2 is given to you. Right? So, okay, 5 moles here, 8 moles here. Okay, what is the stoichiometry of CH4? What is the stoichiometric coefficient of CH4 in the balance equation? 1. So,
1,
divided by 1. And what is the stoichiometric coefficient for O2? Sorry, it's
2.
2. So, divided by 2. This will be coming out to be 4. Right? So, then whichever ratio is less, that will be your limiting reagent. Done. That only will be your limiting reagent. And as I mentioned that the limiting reagent itself will decide the product, how much product should be formed. Is it okay for you? According to limiting reagent, the reaction will proceed. The reaction will proceed. That means, sir, what? See, I have 4 moles of O2 with me, or you can say mole by stoichiometric ratio is 4, and for this I am having 5 CH4. Then this O2 is in lesser amounts, isn't it? Yes, O2 is in lesser amount. Now, if you have this much information with you, then try to read the balance equation first. You have checked. You now know that which is your limiting reagent, which is O2. And now read the chemical equation properly. Read the balance equation properly, please. How can we read it? Sir, it can be read in this way that 1 mole of CH4 requires 2 moles of O2 to produce 1 mole of CO2 and 2 moles of H2O, isn't it? Can I read this equation in this way? Fine?
Yes, sir.
Okay. So 1 mole of CH4 requires 2 moles of water to produce 1 mole of CO2 and 2 mole of H2O. Now go to the question, check the data and find there that what relation they are trying to establish. They are trying to establish the relation between, they want the calculate the moles of CO2. So they want you to establish a relation between the limiting reagent and the CO2. So what is the limiting reagent we got to know? Limiting reagent is O2 uh, and CO2. You have to establish a relation. That means 2 moles of O2 will give me 1 mole of CO2. Yes. But how many moles of O2 do you have in the given data? Sir, I am having 8 moles of O2. So take 8 here. 8 moles of O2. And so to bring this 8, I have to multiply with 4, right? So here also it will be multiplied with 4. So 4 moles of CO2 will be generated. That is your final answer. That 4 mole of CO2 is getting formed. Is it okay? It's fine?
Yes, sir.
Ninal, you also fine?
Yes, sir.
Okay. And then if 4 moles of CO2 is generated, then which is the excess reagent left? O2 is my limiting reagent anyway. Then excess reagent is first of all CH4. CH4 is my excess reagent. And how much it is left? How much it is
One
left?
mole, 1 mole.
How 1 mole? How you have calculated that 1 mole if I ask you? Because I know the relation between CH4 and O2, isn't it? That if I am having 2 moles of O2, it requires 1 mole of CH4. That is my relation. Now, if you have 8 moles of O2, we require just 4 moles of CH4. But I am given with 5 moles of CH4, hence 1 mole of CH4 is left. I hope it is 100% clear to you.
Yes, sir.
Yes? Okay. Then comes the final question for the limiting reagent, and then this concept is also done for us. See this part, the stoichiometry and the limiting reagent part is very, very, very important for us. Very important. think this way. Then say this, N2 gas plus 3H2 gas gives me 2NH3. So this time they have given you the balance equation themselves. You don't have to do that step. Okay. They're saying that 20 grams of this is given, 5 grams of this is given. Consider the above reaction, the limiting reagent of the reaction and number of moles of NH3 formed are. Yeah, this is your thing. You have to identify the limiting reagent of the reaction and you have to find out the number of moles of NH3 formed here.
Sir, limiting reagent is N2, sir.
Limiting reagent is N2, that is fine.
And number of moles of NH3 is formed is 10 by 7, sir.
Sorry,
10 by 7.
10 by 7. What is the exact value you're getting then?
10
1
by
point
7.
something, right?
Yes, sir.
10 is 7. 1.42 something, right? I am not having the answer. Let me try. Let us find it out. So 20 by
Yes.
28 is the moles of this. 5 by 2 is the mole of this, right? So this will be resulting in 2.5. This will be resulting in how much? 20 by 28. It is 0.714. Yeah. And now this is the moles. This is the moles. Then find the limiting reagent. How we can find the limiting reagent? Check the mole by stoichiometry ratio. 0.1714 divided by 1 and 2.5 divided by 3. So what is the 2.5 divided by 3 coming out to be? Coming out to be 0.833. So which is my limiting reagent? Of course, sir. N2 is your limiting reagent. LR. I said, okay. If this is a limiting reagent, then solve the reaction according to this. But sir, what is the reaction? For the reaction, you have to read the reaction. They are saying that 1 mole of N2 requires 3 moles of H2 to produce 2 moles of NH3. 2 moles of NH3. Now, I want to establish a relation between my limiting reagent and my NH3 because that is which they are asking you. So that means 1 mole of N2 gives me 2 mole of NH3 and that means sir you are having 0.714 moles of N2 so it will be requiring 2 into 0.714 moles of NH3 which is I guess whatever you said is correct, right? 0.714. Yes, it should be 1.428. Okay, 1.428 is the exact answer. I hope it is clear to you.
Yes, sir.
Okay, now they are demanding you this exact answer. Okay, like don't stop till 10 by 7. You have to solve it using calculator. 10 by 7, I guess it is giving you some value which is reoccurring value,
One
isn't it?
point, yes, sir.
10 by 7, please don't calculate using that way. I don't know how you are doing it. It's fine. The way, whichever you want to follow, you can do it. But the answer should be this. The final answer should be this.
Sir, if I use 10 by 7 calculator, it is showing 1.429, no, sir. Then
10 by
which is
7, yeah, it's 1.429 it's showing, right?
yes, sir.
Which is not correct.
It should be
Again,
1.428, sir. That
yes,
means
this
dead
is the
accurate.
correct answer. Sorry,
It should be dead accurate, no, sir.
it should be exact.
Yes, sir.
If it is
So
not
we should
exact, they
follow
will
this.
give you a zero. They will give a big zero.
Yes, sir. If we like from starting only, we take decimals, we'll get accurate only.
Yeah, definitely.
Okay,
Yes.
sir.
Okay. Okay, then. If this is also clear to you, then I think this is also done for us. And then see, now we are left with two topics. One is concentration, and the other is thermogravimetry in this chapter, in this unit. And then this unit is done. Okay, I am beginning with the concentration a little bit today. So, what do you mean by concentration? Any idea? How can we feel concentration? What is concentration? Asa, do you guys drink Coke, Thumbs Up, anything?
Yes, sir.
Okay. Fine then. So if you drink it, you find the taste little sweeter, right? Onto the sweeter side. Thumbs up, Coke, both are on the sweeter side. So let me say that okay, if I am having, I have purchased a Coke can or a thumbs up can in this manner. So if I take thumbs up from this end or from this end, will the taste remain same? From any end, if you take thumbs up from any place you take from the can, from here, will the taste be exactly same? Yes, there's no problem in it, isn't it? The
Yes,
taste
sir.
will be remaining same from each and every place from wherever you're taking the thumbs up or coke. I said, okay. So what does the taste tells you? The taste itself tells you about the concentration. And here in the can of thumbs up or coke, it's a uniform concentration which is happening over here. It's a uniform thumbs up, like uniform mixture of products which are mixed in the required proportions, and you are getting the same taste every time. Okay. Then let us try to do something else also. I am taking this thumbs up can. I am adding this to a glass. Okay. Up to here. I think the glass has filled. Then I added a little water here. What happens? What happens with the taste if I ask you? So the amount is increased up to here now. What happens with the taste then? Can you tell me? If I am adding water from outside, what happens with the taste? Will it become lesser sweet now? Yes, sir. Here it was more sweet the normal thumbs up or coke, but after adding water it becomes less sweet. Less sweet means I am already telling you that whatever you can taste, that is called your concentration, a normal concentration basically. Okay, so that means, sir, you are going from a more sweet thing to a less sweet thing. That means more sweet means it is more concentrated, and less sweet means it is less concentrated. That means you are reducing the concentration when you are adding some extra volume of water into it. And let us assume that how Coke is made. Coke is made just with water plus brown sugar. I am assuming this, that Coke is made with water and brown sugar. Brown sugar give its color as a brown. Coke is brown in color, right? So Coke is made up of water plus brown sugar only. Nothing else is there. So sir, here in this case, I was having some water and brown sugar solution mix over here. And then you have tried to add some extra water from outside. So what is happening? My sweetness is getting reduced. That means my concentration is getting reduced after adding more water. I said it's 100% fine. Okay. Then let's say what happens is, let's say I am taking the same volume and the same amount of Coke again. Okay, which was more sweet. Already it was more sweet. And then out from outside, I am adding some brown sugar. I'm adding some more brown sugar. So now what happens? Now what will happen? So the amount remains fixed. The amount will be fixed. And the volume will be fixed, I mean to say. But now the sweetness has increased. It is the most sweet now. Max concentration. Can you feel it? It will be most sweeter. The maximum sweeter it can be. Because I've added more brown sugar from outside, isn't it? That means, sir,
Yes, sir.
here you have increased the concentration. If it's becoming more sweeter, you have increased the concentration. That means concentration is dependent on two things. What solvent you are taking. Okay, the coke, what the coke is, you can say it's a solution. Coke is a solution. Solution is made up of two things. One is solute, one is solvent. Solvent is that thing which is present always in higher amounts, and solute is present in the lesser amounts. That is how we define solute and solvent. Okay, lesser amount, higher amount. I think it's fine. Yeah. So now, because we know that to get a good taste of a coke, obviously water will be in higher amounts as compared to sugar. Yeah, because otherwise it will be too sweety, we can't drink it. So that means, sir, in the case of coke, solvent is your water and solute is your what? Solute is your brown sugar or sugar. I will write. That means, sir, when you are adding more of the solute, when you are adding more of the solute, your concentration was also increasing. But when you are adding more of the solvent, when we add here more water, then my concentration was decreasing. That means my concentration is somewhere linked with the amount of solute and the amount of solvent as well. It linked to both. Yes. And we understand from here that okay, if I increase the amount of solute, my concentration also increase. But if I am increasing the amount of solvent, my concentration falls. Yeah, that means, sir, whatever the concentration you are talking about here is nothing but it's like amount of solute will be like it will be proportional to amount of solute and will be inversely proportional to amount of solvent. Can I say like that? Yes, sir. This is a typical example. It's a typical example. Yes, concentration is dependent like this. I said, okay. Then we like to define this concentration, we have multiple terminologies. Like you might have read about molarity, normality, weight by weight fraction, weight by volume percentage, volume by volume percentage, mole fraction. Many quantities are there. To just tell you this, amount of solute by amount of solvent. To just tell you this. Okay. So the first thing and the last thing which you have to learn in the concentration is nothing but molarity. This is the first concentration term. How molarity is defined? Molarity is defined as a number of moles of solute, which is telling you the amount of solute itself, right? Number of moles of solute is telling you about the amount of solute itself and divided by the volume of solution. Volume of solution is due to what? Sir, if you are having a solution in which you have taken water or any solvent, a liquid solvent, and you have added a solid solute into it, so the volume of solution will not change if you are adding solid solute into it, isn't it? The amount of solution will not that the volume of the solution will not change that much. I mean to say, if you are having, let's say, a glass, and in this glass you have added already water, only water is there in this glass, and then I am trying to add some sugar into it. Will the volume of this water change? Will the volume of the solution will change? So it will be changing in a negligible amount which we can neglect. Getting this point?
Yes, sir.
Mrinal, you also? That
Yes,
I
sir.
was already having water in my glass and I am adding sugar from outside. It will never affect my volume of actual solution because sugar I am adding in a small amount because solute is always added in small amounts. So that means, sir, it is not dependent on the solute amount is not dependent on the or not disturbing the volume of the solution. That means, sir, yes, here if you are writing the volume of the solutions, it is telling you about the amount of solvent only, nothing else. And that is how you define molarity. Very, very, very important for us. Molarity or in AP because they just have two concentration terms. One is molarity, one is mole fraction. Nothing else they have. Okay, so they say concentration as molarity only. This is like whenever they are writing concentration, it means you have to find the molarity. Or if they have given you concentration, that means they are given you with the molarity term. Okay, and what is the unit for molarity now? If I ask you, sir, number of moles is always in mole, and volume is present either in decimeter cube or in liters. So the unit for molarity is mole decimeter minus 3, or you can say mole liter inverse. Is it fine for you guys? This much is clear. I know you know this part a little bit. Yeah.
Yes, sir.
Okay. So this is like remember that the taste which we can feel is your concentration. The taste is your concentration. Okay. The taste can be enhanced. Enhanced means the taste can become more sweeter side if I am talking about the coke. If you add more amount of solute, the taste can become lesser sweet if you add more amount of solvent. That is all for now for this class. This is your all about what the concentration terms we have to talk about. First is the molarity, and we have to think even more about the molarity. Also, one more thing. Let's say if someone gives you something like this, that 1.2 molar aqueous KOH solution I have. What do I have? 1.2 molar aqueous KOH solution. How shall I read this equation? How shall I read this sentence? I can read this sentence that, okay, one more thing. Unit for molarity can be represented as 1 mole per decimeter cube, mole per liter, or can be represented as capital M as well. So they have written it capital M here. So 1.2 M. M means molar. 1.2 molar aqueous KOH solution means what? It means that you fix your volume. You fix your volume to 1 liters. Okay, that means, sir, 1.2 moles of KOH is present in 1 liter of solution. Can I write in this way? Tell me. See, your molarity is given to as 1.2 molar. I am saying that you take the volume yourself as 1 liter. So, if this is 1, denominator is 1, then number of moles of solute will be equal to molarity in the digit, in the amounts. Yes. So, that is what I am writing over here. See, 1.2 molar aqueous KOH solution means what? It means 1.2 moles of KOH is present in 1 liter of the solution. This is how we define the molarity. I hope it is clear. Now we can meet in the next class, and I will be sending you some homework. Okay, for the empirical formula, percentage composition, mass spectra, and your stoichiometry limiting region. Clear?
Yes, sir.
Okay. And I am giving you time to complete this homework by Thursday. Complete it by Thursday. Take some
Okay,
more
Okay,
sir.
sir.
time. Take.
Okay, sir.
Okay. Sure. Okay then. You guys can leave. Thank you so much for the class. Bye bye.